Welcome back to another video. In today's video, we are going to create a hate speech detection model using machine learning. And as a disclaimer, just like we did for the Twitter sentiment analysis video, we'll be using a dataset from Kaggle that contains the extracted tweets. I'll be adding all the links in the description down below. Before moving forward, if you are new to this channel, please hit the subscribe button and turn on bell notification to stay updated each time I upload a new video. Stay tuned. So first, let's import the required libraries. We are importing Pandas and NumPy for basic data operations. We are importing RE to use a regex function. We are importing cbonds and matplotlib to visualize the data. Then we are setting the style using the style function, and we are setting the style as ggplot. Then we are importing word tokenize to perform tokenization. Then we are importing wordnet limitizer to perform limitization on our data. Then we are importing stop words to remove all the stop words. And then we are setting the language as English for our stop words. Then we are importing WordCloud to plot the word cloud. Then we are importing tf-idf vectorizer to vectorize the text documents. Then we are importing train test split to split the data into training and testing set. Then we are importing logistic regression to perform logistic regression on our model. Finally, we are importing the different evaluation matrices which is used to evaluate the model performance. And by the way, if you want to know more about different NLP topics such as tokenization, stemming, etc., I highly suggest you check out my videos on this topic. I'll add links to it in the description down below. Now that we have loaded the libraries, let's load the data. Then let's use a head function to preview the data. Now let's use the info method to get more information regarding the dataset. So as we can see, we have the ID, we have the label and the tweet. The label is the label of the tweet. Now let's analyze some of the text data. Now as we can see, there are a lot of special characters and symbols in our data. Now let's proceed to process the text data. Data processing is done to make the data into a usable format. There are different steps involved to convert the data into a usable format. You can do them individually on the text data, or what I'm going to do here is to create a function that does all of the text processing, and then I'm going to pass my data into it. So let's define the function. And first, let's perform lowercase conversion to convert all the uppercase characters into lowercase. And next, let's remove the URL and hashtag using the regex function. And then let's remove all the punctuations. And then let's remove all the stop words. Let's now apply pre-processing to the text data. Let's also remove any duplicate data. There's one more thing left to do, and that is to perform limitization on the data. Here for this project, I am going to use the WordNet limitizer. You can also perform stemming instead of limitizer. If you want to know how to perform stemming on this data, you can check out my Twitter sentiment analysis video where I perform stemming on the process data. And I'm defining a function here as well. Now let's apply limitation on the process data. Let's now look at the same tweets that were analyzed before performing data pre-processing to see the change. So let's remove this character as well. As we can see, now we have the process data. Now let's use the info method once more to see the updated number of columns as the duplicate entries have been removed. As we can see, the number of columns have reduced to 29,345 from 31,962. Let's now see the distribution of the labels. To do that, let's use the value counts method. As we can infer, there are very less tweets identified as hate speech. We can also visualize the data using a count plot. Now instead of a count plot, we can also use a pie chart to visualize the data. So let's see how to do that. So first, let's define a size for the pie chart. And let's set the color for the 2 sentiments. And let's define the line width and the edge color. Now let's specify the different tags in our pie chart. Now let's specify the distance for how much the wedges should be exploded. And finally, let's add a title to it. Now we have a visual representation of the distribution of the sentiments, where 1 indicates a hate speech and 0 indicates a non-hate speech. Now let's visualize some of the non-hate tweets. And let's use a WordCloud to visualize the non-hate tweets. If you want more detailed explanation about WordCloud, or if you want to take your WordClouds from this to this, you can check out my video on this topic. I'll add links to it in the description down below. So far, we have taken the input data, performed some pre-processing on it, and visualized the pre-processed data. Next, we are going to vectorize the text data using a TF-IDF vectorizer. You can also use any other vectorizations such as count vectorizer. I have used count vectorizer in my Twitter sentiment analysis project. But before proceeding to build the model, let's create a bigram language model. N-gram language models basically mean a sequence of n words. So a bigram language model will consist of 2 words. More on n-gram language modeling in a later video. So let's perform TF-IDF vectorizer on the data and create a bigram language model. Now let's get the number of features and print the first 20 features. As you can see, we have the first 20 features and a bigram language model. Similarly, let's create a trigram language model. So for a trigram language model, we would basically get the features, the second word and the third word. To create a trigram language model, you can just change the number of words as 3. And similarly, we can print out the first 20 features. And there we have a trigram language model. Now that we have vectorized the data, let's proceed to build the model. So first we'll have to separate the data into x and y and then transform the x data. And now let's split the data into training and testing set. So I am taking a test size as 20%. And let's print the size of the training and testing data. Now let's train the data on a logistic regression model. For that, first let's load the logistic regression model. And let's fit the X train and Y train data on the logistic regression model. And then let's predict the values for the given test data. And then let's put in the accuracy of the model. So now we have a model accuracy of 93.17. Now let's print the confusion matrix in the classification report. Now there is another way to visualize a confusion matrix, that is by using confusion matrix display. Let's look at how to perform that. Let's set the style. So now we have a confusion matrix. Next, let's see how the accuracy of the model changes when you perform hyperparameter tuning on the model. Hyperparameters are model parameters whose values control the learning rate of the algorithm. So by tweaking the hyperparameters, you can change the performance of the machine learning model. There are different methods by which you can perform hyperparameter tuning, and for this project, I'm going to use grid search CV to perform hyperparameter tuning. So to do that, let's import grid search CV. And then let's import warnings and filter warnings to remove any warnings that might appear. So here, since we're using the logistical regression algorithm, I'm going to perform hyperparameter tuning on the C parameter. So I'm going to set a couple of C parameter values. Now let's define the grid search along with the classifier. And then let's fit the data. And now let's print the cross validation score and the best parameter. Now let's predict the values for the given X test. And then let's calculate the model accuracy to see if there is any change. And let's print the model accuracy. As we can see, there is a slight improvement in the model accuracy. Now let's print the confusion matrix and the classification report. Now if we compare all the model accuracies, we can see that the hyperparameter tuned model gave the best model accuracy. That brings us to the end of this video. Hope you got an idea of creating hate speech detection model using tweets. Don't forget to subscribe to this channel and share this video with others if you found this video useful. Thank you for watching and see you in the next video.